Hello viewers, in today's session we are going to discuss a very important conceptual problem from definite integrals, and here we have to evaluate this integral that is from 0 to 10, and the integrand is mod of 2 minus mod of x minus 3. And here this is quite interesting to note that we have two mod functions involved in the integrand, right? So let us see how we can easily solve this integral by making use of the definition of mod function. But first we have to redefine this integrand, right? So let us take this integral as I, and let us take this function as f of x. So we have f of x as mod of 2 minus mod of x minus 3, and here we can easily see that we have two mod functions. So we have mod of x minus 3 inside this mod function, right? So before redefining this function f of x, let us quickly see the definition of mod function, right? So mod of p is defined as positive p whenever p is greater than 0, and mod of p is equal to 0 when p is equal to 0, and mod of p is negative p whenever p is less than 0, right? So here this mod function definition is going to be of prime importance in solving this definite integral, right? So let us first take care of this mod function, that is mod of x minus 3. So let us first define mod of x minus 3. So according to this definition, we can now write mod of x minus 3 as positive x minus 3 whenever x minus 3 is greater than 0. So we can take p is equal to x minus 3, right? And mod of x minus 3 is equal to 0 whenever x minus 3 is equal to 0, and mod of x minus 3 is equal to negative of x minus 3 whenever x minus 3 is less than 0, right? So from here, x minus 3 greater than 0, if we solve this inequality, we get x greater than 3. And if we solve this linear equation, then we get x is equal to 3. And from here, we get x less than 3. So now let us combine this definition of mod x minus 3 in the function f of x. So now we can write f of x as mod of 2 minus, and here we can write positive x minus 3 when x is greater than 3, because when x is greater than 3, then mod of x minus 3 is positive x minus 3, right? So here we have f of x is equal to mod of 2 minus positive x minus 3 when x is greater than 3, and f of x is equal to a mod of 2 minus 0, because here a mod of x minus 3 is equal to 0 when x is equal to 3. So here we have x is equal to 3, and f of x is equal to mod of 2 minus, and here we have negative of x minus 3, and when x is less than 3. So inserting the definition of mod of x minus 3 in f of x, we can now define f of x like this, right? So let us simplify all these expressions. So we can now write f of x is equal to mod of, here we have 2 minus, and here we have minus x, then we have plus 3, and this is equal to 3 plus 2 5. So we have mod of 5 minus x whenever x is greater than 3, and f of x is equal to mod of 2 minus 0, that is equal to simply mod of 2, that is simply 2. So f of x is equal to 2 whenever x is equal to 3, and f of x is equal to mod of 2, and here we have minus minus plus, so we have plus x minus 3, and this is equal to x minus 1 whenever x is less than 3, right? So we can now define f of x like this, that is f of x is equal to mod of 5 minus x whenever x is greater than 3, and f of x is equal to 2 whenever x is equal to 3, and f of x is equal to a mod of x minus 1 whenever x is less than 3. So now the status of mod of x minus 3 has led us to this definition of f of x, right? So f of x is equal to mod of 5 minus x whenever x is greater than 3, and f of x is equal to 2 whenever x is equal to 3, and f of x is equal to mod of x minus 1 when x is less than 3, right? Now see, f of x is equal to 2 whenever x is equal to 3. So now in the later stages we'll leave this step, because here f of x is equal to 2, which is a constant function, right? So now we'll consider only these two parts. So now we can write f of x as mod of 5 minus x whenever x is greater than 3, and f of x is equal to mod of x minus 1 whenever x is less than 3. So now let us define a mod of 5 minus x with the help of this definition. So mod of 5 minus x is positive 5 minus x when 5 minus x is greater than 0. So it implies x is less than 5, and mod of 5 minus x is equal to 0 whenever 5 minus x is equal to 0. So this implies x is equal to 5, and mod of 5 minus x is equal to a negative 5 minus x whenever 5 minus x is less than 0, or we can write x greater than 5. Now similarly we define mod of x minus 1. So mod of x minus 1 is positive x minus 1 whenever x minus 1 is greater than 0, it implies x greater than 1, and mod of x minus 1 is 0 when x minus 1 is equal to 0, this implies x is equal to 1, right? And mod of x minus 1 is negative of x minus 1 when x minus 1 is less than 0, that is x less than 1. So now let us draw the real number line here. So here we have the real number line, and let us represent the points. The first one is 0. So here we have 0, then we have 1, then we have 3, and then we have 5, and then we have here 10, right? So 0 is our lower limit, 10 is our upper limit, and apart from 0 and 10 we have three more points. The first one is 1, which can be obtained from mod of x minus 1 by taking x minus 1 is equal to 0, so x is 1, right? And the second point is 3, which can be obtained from here, that is mod of x minus 3. So we can have x minus 3 is equal to 0, so x is equal to 3. and this point x is equal to 5 can be obtained from mod of 5 minus x by taking x minus 5 is equal to 0. So we have x is equal to 5, right? So on the real number line, we have represented these 5 points, including the lower limit and the upper limit 0 and 10 and 1, 3 and 5. So let us once again come to mod of 5 minus x. Now see, here we have mod of 5 minus x when x is greater than 3. So let us concentrate on this point, that is x is equal to 3. So when we have x greater than 3, it means we have to consider all the points which lie towards the right of x is equal to 3. So we have to go like this, right? So here when we have x greater than 3, then we can form two intervals. The first one is from 3 to 5 and the other one is from 5 to 10. And similarly, when we consider f of x is equal to mod of x minus 1, we have x less than 3, right? So again, we have this point, that is x is equal to 3. And now we have to consider all those points which lie towards the left of x is equal to 3, right? So here we have to go like this. So in this case, we have to form two intervals. One is from 0 to 1 and the other one is from 1 to 3. So when we consider mod of 5 minus x, we have to go from 3 to 10 and we form two intervals. First one is from 3 to 5. The second one is from 5 to 10. And when we consider mod of x minus 1, we have to go like this, and we have to form two intervals, first from 0 to 1 and second is from 1 to 3. So let us once again come to mod of 5 minus x. So here we have mod of 5 minus x, and let us consider this inequality. Now see, here we have x less than 5, and here when we have f of x is equal to mod of 5 minus x, we have x greater than 3, right? So when we take mod of 5 minus x is equal to a positive 5 minus x, so we have to incorporate x greater than 3 but less than 5, right? So here now we have x greater than 3 because this condition is always there when f of x is equal to mod of 5 minus x. So when we go from 3 to 10, then we have here x less than 5 and here we have x less than greater than 3. So combining these two inequalities, we have x greater than 3 but less than 5. And then here we have 0 when x is equal to 5. And when we have x greater than 5, then we'll write here minus 5 plus x, and because here the last point is 10 because our upper limit is 10. So when we take x greater than 5, then we have to write x greater than 5 and we have to restrict ourselves to only this point, that is 10. So now the modified form of this function is mod of 5 minus x is positive 5 minus x when x is greater than 3 but less than 5. This is 0 when x is 5, and this is equal to minus 5 plus x when x is greater than 5 but less than 10. So now let us consider this function. So we have mod x minus 1. Now here when we consider f of x is equal to mod of x minus 1, we have this condition x less than 3. And here mod of x minus 1 is positive x minus 1 when x is greater than 1, right? But we have x less than 3. So combining these two inequalities, x less than 3 and x greater than 1, we can now write x greater than 1 but less than 3. And mod of x minus 1 is equal to 0 when x is equal to 1. And mod of x minus 1 is equal to negative x plus 1 when x is less than 1, right? So when x is less than 1, here the lower limit is 0, so we have to restrict ourselves to this point, that is x is equal to 0. So here we must write x greater than 0 and less than 1, because we have to confine ourselves to 0 and 1, right? So now the refined form of mod of 5 minus x and mod of x minus 1, due to these two inequalities, we have this form of mod of 5 minus x and mod of x minus 1. So now we are in a position to redefine this function f of x in these intervals, right? So here we'll write f of x, and first we will consider this interval, that is 0 to 1. So here we have x greater than or equal to 0 but less than 1, right? So when x is greater than 0 and less than 1, we have the form of f of x is equal to a negative x plus 1, right? Then we go from 1 to 3. So we have to consider this one. So f of x is now equal to x minus 1, and we have x greater than or equal to 1 and less than 3, right? Because mod of x minus 1 is equal to x minus 1 when x is greater than 1 but less than 3. And when we have this interval, that is 3 to 5, then we have this one. So we can now write 5 minus x, and here we have x greater than or equal to 3 but less than 5, right? And when we consider this interval, that is 5 to 10, then we have this one, that is minus 5 plus x, and here we have x greater than or equal to 5 but less than or equal to 10, right? So this is our lower limit, and this is our upper limit. And this is very much clear from this function that f of x is equal to 0 when x is equal to 1 and x is equal to 5. So at these points, that is x is equal to 1 and x is equal to 5, the function f of x is equal to 0. So viewers, this is the complete representation of the given integrand, which is our function f of x, and we have defined f of x as a piecewise function within these two limits, that is 0 to 1. So we have confined f of x within 0 and 10, and f of x has 4 parts, including f of x is equal to 0 when x is equal to 1 and x is equal to 5. So now we are in a position to evaluate this integral I. So here we can see that if we define the function as y is equal to f of x, then y is equal to minus x plus 1 when x is greater than or equal to 0 but less than 1. Y is equal to x minus 1 when x is greater than or equal to 1 but less than 3, and 5 minus x when x is greater than or equal to 3 but less than 5, and here minus 5 plus x when x greater than or equal to 5 but less than or equal to 10. So here this function y is a linear function, right? And here these 4 equations represent the equations of a straight line. and these equations are of the form y is equal to mx plus c. So now the value of this integral I can be represented as a sum of four integrals. The first one is from 0 to 1, that is 0 to 1 f of x dx. Then second one is from 1 to 3, 1 to 3 f of x dx. And then we have 3 to 5, 3 to 5 f of x dx. And then we have 5 to 10 f of x dx. So let us call these integrals as I1, I2, I3 and I4. So I is the sum of I1, I2, I3 and I4. So let us calculate the values of I1, I2, I3 and I4 individually. So I1 is from 0 to 1, and f of x is defined as minus x plus 1 dx. I2 is from 1 to 3, and f of x is defined as x minus 1 dx. And then we have I3 3 to 5, and f of x is defined as 5 minus x dx. And I4 is from 5 to 10, and we have minus 5 plus x dx, right? So now we can easily calculate the values of these four integrals. So now I1 is minus x square over 2 plus x. Limits are from 0 to 1, because the integral of x is x square over 2, and integral of 1 dx is simply x. And here we have x square over 2 minus x. Limits are from 1 to 3, and here we have 5x minus x square over 2, and limits are from 3 to 5. And here we have minus 5x plus x square over 2, and limits are from 5 to 10. So now I1 is given by substituting the limits and taking the difference. So we have minus 1 square over 2 plus 1, and then we have x is equal to 0. So here we have 0 plus 0. So this is minus half plus 1, that is simply half. And I2 is given by x square over 2 minus x. Limits are from 1 to 3, so we have 3 square over 2 minus 3, and then we have 1 square over 2 minus 1. So this is 9 by 2 minus 3 minus half minus 1. So this is 3 by 2, that is 9 minus 6 over 2, that is 3 over 2. And here we have minus half, so this is 3 by 2 plus half, that is 3 plus 1 4, 4 over 2 is 2. Now I3 is given by here 5x minus x square over 2. Limits are from 3 to 5. So we have 5 times 5, 25, minus 5 square is 25 over 2. And here when we take 3, we have 15 minus 9 over 2. So this is 50 minus 25, that is 25 over 2. And here we have 30 minus 9, that is 21 over 2. And this is 25 minus 21, 4, 4 over 2 is 2, right? And now we have I4. I4 is minus 5 times 10, that is minus 50, plus 10 square is 100. 100 over 2 is 50. And then we have here 5, so we have minus 25 plus 5 square is 25 over 2. So here these two terms get cancelled, so we have minus 25 over 2, that is simply 25 over 2, right? So I1 is half, I2 is 2, and I3 is also 2, and I4 is 25 over 2. So now I is the sum of these four integrals. So we have half plus 25 by 2 is 26 over 2, and here 2 plus 2 is 4. This is 13. 13 plus 4 is 17, right? So viewers, the value of this integral I is equal to 17. So now let us consider the geometrical interpretation of this integral I. Now see, from the definition of definite integrals, we know that a definite integral represents area bounded by curves, right? And here we have calculated that the value of this integral is equal to 17. And if we plot the graph of this function f of x, which is given by mod of 2 minus mod of x minus 3 in these four intervals, then we'll verify that the area bounded by this function with x-axis is equal to 17 square units. So let us verify. So in the first case, we have the line that is y is equal to minus x plus 1. So we can write this line as x plus y is equal to 1, and this line is of the intercept form, that is x over 1 plus y over 1 is equal to 1, which is of this form, x over a plus y over b is equal to 1, right? So if we plot this line in this interval, that is 0 to 1, then we have the line like this, right? Because this line passes through 1, that is 1 comma 0, 1 comma 0, and 0 comma 1. Now let us plot the second line. So now the second line is y is equal to x minus 1 in the interval 1, 2, 3. So let us rewrite this line as x minus y is equal to 1, and this line is again of this form. We can write it as x over 1 plus y over minus 1 is equal to 1, right? So this line should pass from 1 and minus 1, but here we have to restrict ourselves to only 1 and 3, right? So we can draw this line like this, that is this line will go like this. So here we have the line x over 1 plus y over minus 1 is equal to 1. So now when we have x is equal to 3, then f of x is equal to 2, as we have calculated in the beginning. So when x is equal to 3, then f of x is equal to 2. So here we have f of x is equal to 2, that is y is equal to 2 line. So the line y is equal to 2 is it can be drawn like this. Now let us come to this line, that is y is equal to 5 minus x, and here the interval is from 3 to 5. So we can write this line as x plus y is equal to 5, and this line is again of the intercept form, that is x over a plus y over b is equal to 1. So this line should pass from 5 and 5, right? So we can draw this line like this. Now come to this line. So here we have y is equal to minus 5 plus x, and the interval is from 5 to 10. So we can write this line as x minus y is equal to 5. This can be written as x over 5 plus y over minus 5 is equal to 1. That is in this form. So when we draw this line, x over 5 plus y over minus 5 is equal to 1, then this line passes through 5 comma 0 and minus 5 0 comma minus 5, that is 5 comma 0 and 0 comma minus 5. But here we have to restrict ourselves from 5 to 10. So this line will appear like this. So here we have this line, that is here we have 10, and here we have 5, right? Because when x is equal to 5, then y is equal to 0. And similarly, when x is equal to 10, then the value of y is equal to minus 5 plus 10, that is 5. So the line y is equal to 5. This line will go like this. So here we can draw the line like this. So now let us call this point as A, this is point B, this is C, this is D, and this is E, this is this point is say F, and this point is G, right? So the line AB is given by this equation. So this is line AB, and then the line BC is given by y is equal to x minus 1, and CD, the line CD is given by y is equal to 5 minus x, and the line DE is given by y is equal to minus 5 plus x. And here the line GC is given by y is equal to 2, and the line FE is given by y is equal to 5. So now the area bounded by this integral I is given by this region, that is the area of this triangle, the area of this triangle, and the area of this triangle, right? So this function f of x, we have drawn this function f of x within the limits 0 to 10, and the area bounded by this curve f of x with x-axis is given by the sum of these three, the areas of these three triangles. Now let us here see an interesting thing. Now see, when we have here a mod of x minus 3, then x is equal to 3 is a corner point, right? And here we have x is equal to 3. So we have to break this triangle into two areas. That is here if we take say EFGH, so we can take this point as H. So the triangle BCD, it can be written into two parts. The first one is triangle BCH, and the other is CDH. So now the total area represented by this integral I is given by area of triangle OAB. Then we have area of triangle BCH, and then we have the area of triangle CDH, and then we have the area of this triangle, that is DE, here EFGHI. We can here denote this point, that is 10, as I dash or I prime. So we have DE I prime, right? So the integral I is now the sum of the areas of these four triangles. To find the area of a triangle, we'll use the well-known formula, that is half base times height. that is the altitude. So here in the first case, area of triangle OAB is given by half. The base is if we take this origin as O, then OB, and the height is OA. So this is 1 times 1, and then we have the triangle BCH. So the area is given by half. The base is 3 minus 1, that is 2, and the height is here 2 minus 0, that is simply 2. And the area of the triangle CDH is given by half. The base is 5 minus 3, that is 2, and the height remains the same, that is 2 minus 0, that is 2. And the area of the triangle DEI dash is given by half. The base is given by 10 minus 5, that is 5, and the height is given by EI dash or EI prime, that is 5 minus 0, that is 5. So now we have here half, and here 2 and 2 get cancelled, so we have 2. Here also 2 and 2 get cancelled, here we have 2, and here we have 25 over 2, right? And we can see that this half represents I1, this 2 represents I2, and this 2 represents I3, and 25 by 2 represents I4. So when we add all these four numbers, we'll get 17, right? So the area bounded by this function with x-axis is given by the sum of the areas of these four triangles, 1, 2, 3, and 4. So this is how we can make the geometrical interpretation of this integral I.